G'day there, you're watching the Aussie BIM Guru, and today we're going to run through the second part of my tutorial series on creating content and families in Autodesk Revit. So our last part we dealt with the initial planning of the family. Today we're dealing with reference planes, geometry and constraints. So actually doing the family. So this is the overall workflow we're working through, so we'll look at some later sessions where we look at parameters and coding, and also some graphical settings. If you're looking for that, then feel free to skip ahead. So you can see the workflow is this with a method, a framework. So today we're doing the framework, and then a system and a polish. So here you can see where we are on the workflow today. Okay, so I guess this is the goal for the end of today, to actually build a table that's relatively detailed, looks quite good in 3D, and is usable in Revit projects. So we're going to start with reference planes. It's important to do them before you model any geometry, in my opinion. See them like a skeleton or a framework for what you're building. So these will hold the thing together, essentially. So this is why it's important to have it there before the geometry, so that we have something to constrain things to, ultimately. So with reference planes and lines on the ribbon, you can do other lines or planes. We're going to work with just planes today. Reference lines are more when you're dealing with something that has a finite length. So basically, if you have a constraint that is rotating about a point, you would use a reference line instead of a reference plane in that case. So types of reference planes, so there's a lot of different types you can set. There's the ones that basically are by common name, so front, back, left, right, center back. These are inbuilt reference planes, and it's good to define them because it means content understands how to change dimensions as you swap it between other elements. You've got strong references and weak references, and then not a reference. Most of the time, I set most of my reference planes to not a reference because all they're doing is holding geometry together, and you don't want to dimension them in the model itself. It's important to understand the difference between strong and weak reference planes. So strong reference planes will dimension and snap with priority before weak reference planes. So if you're working at quite a small scale, and you're hovering a dimension around a table, it will typically let you dimension to the strong plane before you tab select a weak plane, if that makes sense. Strong reference planes will typically move a family if they're adjusted, whereas weak ones will move with the family instead. So if you have a major reference plane, such as one pulling a bench length, then you'd probably use a strong plane versus a weak plane. So just to call back on what we were showing in the first part, so these are our strong or our named planes. You can see the origin that I've defined here as the front, back, and left, right point of the family, so the center of the family ideally, and a top for the table surface, and a base, which is the host level in this case. And then some weaker, not a reference planes. So without further ado, we'll actually go and set up these reference planes. So I'll just jump into a demonstration at this point. So I'll set up a CAD file that just has the line work of what we need for the family that I've drawn in Revit previously, just as a reference. And this is today's goal, just to prove that we are actually going to build a Revit family, ultimately, that will have reference planes driving the family as well. So we'll close that. And we're going to make a new family. And we'll just go to our family templates. And we're going to make this a piece of furniture. So we're going to use the furniture template. So to begin with, we have a center left, right, and a center front, back reference plane. So we want to actually bring in our CAD at this point, just as a reference. It's important that you clean up your CAD file that it has, so it just has 1 or 2 layers on. I've just left layer 0 because it's easier to clean. So we'll just do millimeters, orient to view, and what we'll do is position this so that the center of the table in the CAD file is coincident with the center of the table here. You don't always need to use a reference CAD file. You could actually just draw it based on a technical brochure off to the side. But I find sometimes this can be easier for more complex families. So we'll just bring in one into front as well. And I'll show you quickly what this looks like once we bring these in, just so you can see what I'm setting up. So essentially what these CAD files do is give us something we can draw against, and also something that we can reference in 3D with our family. So you can see that they more or less represent the origin of the family here, and we'll get rid of those when we're finished. So we're going to create some reference planes. So if you go to create reference plane, or RP, for shortcut, it will let you create a reference plane. So by default, we just want to use the settings as they come. You can say is not a reference when you make it if you want. Sometimes I prefer to do this after I've made my main references. So we're going to create our primary reference planes first. Typically you try to make them go beyond your family's extent, just so it's easier to review the family. So we'll make that our back plane. So what we can do is actually name this, but I'll just do them all first and then name them after. I'll just use the align tool to get that exactly where I need it. And we'll just do this one here for left. And we'll use the mirror tool for right. So that's in floor plan, in front view. We just want one for our tabletop surface. And that should do. We'll also create a plane at this point just for the bottom of the table. At this point, what you need to do is name your reference planes. So this one is top. This one will just be we'll make it a strong reference. This one we'll call left. And you'll see that I'm setting the reference type and also giving it a name at the same time. Because when you're in the project, you'll actually see that name as you go to align to aspects of that family. So you'll see down in the bottom left there, you'll see it's actually telling me the name of the reference plane. And similarly, you'll see that in a project if you hover over that particular plane outside the family. Sorry, that's not bottom, that's back. So I'll just make that a back plane. And this one a front plane. And also at this point, we could set up some dimensions on these reference planes. So we're going to use a constraint on these. And I might just jump back into my tutorial session just to run through what constraints are. Actually first, I'll set up some minor reference planes as well actually. So at this point you can really just go copy multiple. And I might just do one first and then change its name, because net reference planes will start automatically naming themselves if you're not careful. So if I copy one with a name, it'll try to rename it to something logical beyond that. So we're just going to get all our primary points of reference at this point. So I'll get one for the center point of those table posts, which I believe, just try and get a hold of it. I think it's halfway, 25 mil. Great. And once you've got a set of reference planes, you can mirror them about axes if you want. So I can take all those and just mirror them across. Likewise, we're going to take these planes here. And you don't have to be too careful with how you set them up at this point. Just deselect CAD file, and we'll mirror those across as well. And we'll just make one for the front of the table drawer as well. And we'll create a plane for the end of this ellipse and the center of that ellipse. Okay, the only other planes we need to make at this point are for the drawer protrusion. Use the align tool again. And you'll see this part of the exercise isn't overly exciting, but it's important to get these all right at this point. Okay, so at this point these are all set up. So pretty much all of these you're going to want to make not a reference. I find the easiest way to do that is to isolate category on them. So IC, or down here, isolate category. Select all of them and then just deselect your primary reference planes at that point, which I believe are these ones and these ones. Okay, and then if you go not a reference on those, that's an easier way to sort of control those references. I'll just double check. I think I set one of them by accident. Great. At that point, we'll go into our front view and we'll set some of these planes here as well. So this is our top plane. We'll get the table thickness for the finish and we'll copy this down for the drawer. That for the center line of the handle, which we'll need to constrain. From there, we need to copy down to a point where the table leg straightens out, because that will be the point where our family grows from. If you remember the last session that we did, you'll remember how that worked. I'm just going to create a line just to assist me in placing this particular point. So the good thing about having CAD in is you can do a pick line in order to get the right point. And there you go, we can see that. That's our point there. So we'll copy a reference plane down there. And some of these things I'm setting up with the intent of making this family parametric later. So you remember this is our growth zone where our family will be able to get larger in size. And then we'll copy these down here. And likewise, we can take all these planes and make them not a reference as well. There we go. And I think beyond that, we just need some planes for these. So sometimes some reference planes, you won't notice the need for them until you get to a particular point in your project where you see them in a different view. I'm just gonna make those 10 each. Okay. And I'm just going to mirror those about the axis. And even though I'm creating reference plans in front view, I'm technically actually also creating them in this view as well at the same time. So those reference plans are here as well. So you see what I mean when I say that reference plans are 3D and they extend infinitely. There we go. So that would be a basic set of constraints. So at that point, we'll go back to my reference material. So it's important now to set up our geometry after our references so that we're able to constrain to them. So geometry tools are basically under the Create tab, and there's a whole bunch of them, and they all do different things. So extrusions are basically a straight loft from face to face. Blends are a loft between two different faces. Revolves basically cast a profile around an axis. Sweeps and swept blends are, I think, pretty self-intuitive. A sweep runs a profile along a path, and a swept blend goes between two profiles along a path. Void forms contain all of these, available as subtractive geometry to take away. Model lines, not that useful, but typically can be used for graphics that you want to see in elevation, for example. Components are how we can place nested families, and model text we don't regularly use, but it is what it sounds like, it's model text. So these are our basic modeling tools. So basically we need to start constraining when we do this. So that's the locking of elements or data based on either locking constraints or nesting constraints. So we don't want to constrain two geometries, so don't constrain one extrusion to another, because that has the tendency to bring a family apart. If one of those elements is deleted or modified and people don't realize how it's constrained, it can do a lot of damage to the family. It can potentially lead to corruption in very complex projects where that family might be nested in other families. So only do it if it's absolutely necessary, if there's no other way to constrain something. And we need to set our work plane to do that as well. So it's good to not always just draw on the work plane of the view that you're in. So if you're on a floor plan, you may not always want to be working at the floor plane of the level. The way you can set that is in your Create tab. Under work plane settings, you can actually change the work plane that you're currently working in. So as I model, you'll see me sort of change my work plane a few times here and there. I find pick a plane quite useful, especially if you're not naming all your reference planes you want to use. But we'll set up our geometry. Prior to that, I'm just going to start adding some dimensions. So even though we're not adding parameters yet, it's good to add dimensions to lock things in place. So for example, we can set up an equality constraint on our width and then lock down our width, and we'll go to 1 to 5 so it's easier to see what's happening. Likewise, we could do the same. It's good to make sure all your primary reference planes have key dimensions between them, and I don't like doing strings of dimensions across the entire thing. I prefer to constrain things off major reference planes. So from here, I would then go on to constrain this set of reference planes here, and that's much easier. So constrain is if you're thinking about how you're going to parameterize your family. So which things are going to be flexible and which things aren't. And those things that are going to be flexible should be set up in a way such that you can assign a parameter to one of these. So say this crossbar was parametric in width. This would allow me to nest a parameter later on. But for now, I'm just locking them down. So once you've done all these and went to front view, I'll just open up a family that I've prepared earlier so you don't have to watch me do every single one of those. So I think this is references dimensions. So at this point, I've pretty much dimensioned my major references. I think if I go one step forward, so I think that's, sorry. Actually, if I go to this step here and I'll just remove my geometry, this should leave behind my reference planes fully dimensioned. There we are. So you'll see that I've set up all my dimensions to constrain my family. So I've sort of worked off my major references in each case, same in my front view as well. And you'll notice that I do all my vertical constraining in elevation and all my horizontal constraining in plan. I find that's much easier to track down constraints. So I technically never have to do any constraining in left or right, only in front and floor plan. Okay, so we'll start setting up some geometry. The first thing we're actually going to work on is the leg of the family, because it's quite a unique element, and it'll show you how some geometry tools can be used. So we're just actually going to create a new family. I might actually just go and open one that I've done earlier and then just delete the geometry to save some time. So we're aiming to build a leg, and then we'll use this as a nested family in the project. So if I go to front view and I go to insert and import CAD, and we'll just import that CAD again. and we'll just position it so that the leg is centered on here. And I've basically created a new furniture family for this leg. So relatively straightforward. So what I've done from there is I've set up a reference plane here, because this is the point where my leg will technically start changing size. So if I pick line here, you'll see this is where the curve tapers into a straight section. So this is my area of growth in the family. If the table gets higher, I want this to stay the same, that to stay the same, and this will flex. And then likewise, I've set up some reference planes to constrain some geometry in the family. So this will be able to constrain a blend, this will constrain a revolve, this will constrain an extrusion, and this goes to the tabletop. Currently it's not parametric, but eventually what we will do is set up a height parameter for the leg height, and we'll connect that to a formula at the family level. So we'll create a flexible dimension and leave it there for now. But all we're going to do now is just start creating geometry. So we're going to check our work plane. It should be center, front, back. And we'll do a blend first. So blends, we'll do the revolve actually. So revolves expect an axis line. So what are they rotating the profile about? So you need to set that first. So you'll see I pick that, lock it, and then we need to draw the boundary. And in this case, you can constrain it as well. So we'll draw a boundary line, and we're going up to here. And I won't lock these because they're not good to lock to CAD files, because we will ultimately delete that CAD file. Okay, and we'll just trim these all up. And what the revolve should do, once I trim these, is it will cast a profile around that axis. And you can change how far it goes, 180 degrees, 270, 360, and that's how a revolve works. So they can be quite handy for circular or cylindrical geometry. We could do a revolve for this as well, but I'm going to do an extrusion instead, because extrusions are more friendly to work with, I find. You'll see I haven't changed my work plane yet, but what I can do is go back to front view, and I can set its work plane by going edit work plane, pick work plane, and pick this, and now it's working off there. And what I do from here is align the top and the bottom of the constraint to the reference planes. Note that I'm always doing reference planes. Okay, now we'll do another revolve, and instead of starting a new revolve, you can just copy an old one if you so choose, and then modify it from here, because the other one will be left alone at this point. Okay, so we'll do our boundary, which is here to here. Take our middle boundary line, and then we will just pick these three lines without locking them. And likewise, as it did before, you'll see that it'll revolve that profile around again. So quite a handy tool for relatively ornamental objects. Sometimes curves can bug out in 3D a little bit, but when you go to render it, it should be fine. It's just Revit struggling to convey the geometry in hidden format. Okay, the next thing we need to do is do a blend. So we're going from a circle up to a square. So it's a transition of profile. So we're going to do our base, and we're going to do a 20mm base, and our top is 50 by 50. And I'll just position that after, and we'll center that on there. There we are. And we'll just change the work plane to here. And blends are quite easy because you can just lock their base like an extrusion once you've got those two profiles in place. Great. And then the last thing we need from there is another extrusion. So we'll just do an extrusion. Draw that. Set its work plane to here. And again, constrain. And it's quite easy. So you see all these dimensions are locked down. So the way all this constraining is going to work is basically if this gets any higher, something funny, because I've actually run into a bit of an error here. So I'm going to show you a workaround that we can use for complex geometry. So basically the way this family is going to work is this is always going to be the same height. So what we'll do is take out some constraints here. And basically we're going to want to constrain between here and here. And we're going to want to host all these elements between this zone. Because they're not behaving too well. So mainly because we have a set of curves here that are struggling to resolve their constraints when they change height. So the easiest way to deal with this is to create the zone that you want to fix elements between. And then we'll create our flexible zone here. Well, not currently flexible, but could be. And this is our flexible height here. And what we'll do instead is we'll group the elements that aren't behaving. And we'll just call this leg piece 1. group. Great. Okay. And then from there, inside that group, we'll add a reference plane that we can use to constrain the group instead. And we'll disassociate these elements from a work plane, just so they're free and don't get driven by any reference planes anymore. And then at that point, we've got a piece that basically moves freely. And we can lock that. And now when I change this, yeah, so now you can see it's working. The only thing we need to do is constrain this extrusion here. Great. So now you see as I move this up, the leg piece will move up as well. And that allows this to be parametric. So if I make this a meter, you'll see that my leg can adjust. So this is prepared basically to be parametric in the next stage. Okay, so at that point, what we can do is actually load this family down. I've just changed the type name to leg, just so it's more clear. We'll run through information in the third part. Okay, so we'll go to place a few of those. So we'll place component on work plane, make sure our reference plane is the right one, which is the reference level. We'll create 4 legs, and we can basically use the align tool now to lock these to reference planes. So this is, I guess, a component, which is a nested family. And it means that we don't have to model something complex more than once by using this. So it saves a lot of time. And we won't make these parametric just yet. We'll do that in the next part. So once these are all constrained, you'll sort of see what the outcome is. So we'll just constrain this last leg. And if we go to 3D, you'll see that that's more or less what we've achieved by doing this. So what we'll do now is we'll just model the draw. So if I just model an extrusion, and when you model an extrusion, it's quite easy. You just pick the planes that you want. Don't worry if they overlap. You can always trim them when you're done. The only complicated part is if you end up in a situation where you want to split some planes, just be mindful that when you split it, it will basically find the more important half and constrain it, and the other half will become unconstrained. So just be mindful of that. So things don't automatically constrain themselves. You always have to tell them to. Even if you copy an element, it will be copied with all its constraints not applied anymore. It would be nice if Autodesk did actually implement a copy with constraints feature, but still waiting on that. And you'll see I'll just mirror these across, trim these up. You'll see when I mirrored those across, they didn't constrain themselves. So we have to reconstrain each of those. There we go. I'll probably cut ahead a few steps here and there. So if you see any fade outs, I'm just saving some repetitive stages. Okay, so that's the draw base. You'll see it's not on a logical work plane. So what we can do is pick a plane and we'll just post it to its base. And even though it's hosted to it, I usually like to lock it as well. And there we go. And you can also nest height parameters into these as well if you want. So you can nest parameters to control the heights of these. And there you go, that's our draw base there. Then we'll take our draw, and assuming we've got an extrusion that's sort of in the right location, we'll just take that one's geometry at least. And we'll take the draw. I haven't actually set up a couple of reference planes for the edge of the draw, so we could do that as well, but I'll just skip that for now because it's not an overly critical constraint. And I'll just show you how to do the draw handle because that's an interesting one as well. Okay, and then we constrain that to probably the center of the draw. And then we can lock the base, lock the top. So the next thing we want to do is we actually want to draw a revolve in plan to achieve the handle. So we want to set our work plane to the center of the draw, and we want to draw in floor plan. So we're going to do a revolve, and our axis line is going to be about this line here, and our boundary lines are going to be basically what we need to generate this profile. So we'll constrain what we can. Notice that I didn't constrain to a reference plane. There we go, that's better. This element's a bit more complex to constrain. It's basically a partial ellipse. And what we can constrain of it can be achieved by turning on a center mark. So center marks are available for anything circular. So if I select a circle, you'll see I can turn on the center mark as a method of constraining. I didn't know that for quite a while when I built families, and I used to go to some very strange lengths to constrain circular geometry. So really important to understand that workflow. Okay, and I'll just trim this up. And there you go, we've got a handle in 3D. and you'll see that's circular and more than detailed enough to achieve what we need. So from there we can model up the countertop. The countertop's quite straightforward. I'll just model one and probably skip the other and then come back when it's all together. But basically it's just going to be an extrusion modeled on top. And I've actually went to the point of saying that the countertop will be made out of two pieces. It'll be made out of its substrate and its laminate, like the actual product is from IKEA as well. Because I prefer families to be as accurate as possible when the information is known. You'll see there, we'll just lock this to the surface. And it's important to see here that if I copy this countertop, because obviously I want to just do one that's a bit lower, the copy isn't going to have any constraints on it. So we'd need to reconstrain. So that's where the copy with constraints tool would be, really helpful, because we could really quickly copy things that are basically the same element but slightly lower, and they would have their constraints already applied. But maybe in the next version of Revit. Cool. So that would be like, I guess, the very basic framework of a table. I might skip forward just one step to show you the next step I went to with the geometry modeling. So at this point, when I was finished, the other elements that I've added are the crossbars underneath, which are hosted to a reference plane under here. They're just extrusions, and then just also the table extension as well. And in the next step, we'll actually look at animating that by modeling a copy of it here that can fold down, and just a support bar for each of those. So that's pretty much, I guess, the geometry modeling done. One extra thing you can do in your family environment, if you find it easier, is actually go to Manage Object Styles, and under Annotation Objects Reference Planes, you can set up object styles or subcategories for your reference plane, so major and minor, for example. And you can actually set up strong reference planes as a subcategory if it makes your life easier. But at that point, I guess what we have here is a family that is suitable for use in Revit from a 3D sense, but not from an information or a BIM sense. So if I go and load this in, notice I've also ticked on workplane based and shared. So shared basically means if I nest this family in another family, it will source the project's version and let you tag it and schedule it as its own object still. If it's turned off, it treats it like a piece of geometry in the family. So these legs, for example, are not shared. And as a result, when they get loaded into the project with the table, they don't become part of the project. They belong to the table. Workplane based, I'll show you how that works as well, because I really like making most of my families workplane based. So I'll just load this into the project. And we'll just go on 3D. So notice you have this place on workplane or face dialog. So this is part of a workplane based family. So if I click and I go to 3D, you'll see there's a copy of our table. And notice I can't select the legs because they're not shared. So they don't actually come through to the project browser. So you can't select them. But you could set them to be shared if you so chose to bring them through to the project. So from there, I can copy lots and lots of these if I want. If I go back to floor plan, I should be able to dimension on my strong planes. So notice these are appearing as snap points. So it's quite important. Notice down in the bottom left corner, it's telling me what those references are as well. And if I place a new one, you'll notice I'm placing it on its origin. So it's coming in on its origin point. I'll just quickly show you that shared thing I was talking about. So if I open this family and I make it shared and I load it back into that particular version of the project. So now these are shared families basically. If I load this into my project again and I overwrite that family, you'll notice that now the legs are actually an own individual family and I can actually schedule them, count them. But in this case, that's not very useful because the table's going to have 4 legs all the time and it's really part of the product itself that we would procure. So that's the difference between shared. Okay, so that's really, I guess, today's session covered. So the next session, we're going to look at parameters and formulas and how we can actually make this a parametric family that can have different types and sizes, and also how we can code it, so how we can set things up that can be tagged and scheduled as well. So feel free to join me on the next one. It should be out shortly, if it isn't already. Thanks for watching today, and if you have any comments about the workflows or what you've seen today, just let them down below. And if you want to follow and subscribe, and if you like what you're seeing, feel free to do so. Thanks, take care, see you on the next one, bye.